Was prepared by PierPaolo Monfardini, a conservator in private practice in Bologna. Due to a last-minute family emergency, PierPaolo wasn't able to make the trip here today. But Chui, my colleague in the Paintings Conservation Department here at the Getty and our resident panel expert, has not only, over the past couple of days, translated the entire paper into English, but she's valiantly offered to present it to us today. So I will turn the podium over to Suan.
I just wanted to give a brief introduction to PierPaolo Monfardini, whose bio is not in the packet. He apprenticed as a furniture and intarsia restorer in Bologna, and it was through Dr. Giorgio Bonsanti, who's in the audience today, that he was introduced to the field of conservation, and thereafterwards was able to work in the laboratories of the Opificio delle Pietre Dure. Until recent times, it was believed that thinning wooden supports of paintings on panel to help force the picture surface into a flat plane was a definitive solution to resolving the aesthetic and structural problems of the painting. Analysis of past interventions and their current state of conservation has demonstrated that this type of operation completely altered the work and significantly increased the problems associated with the stability of the support and the coherence of the surface, which consequently affects the appearance. It is not accidental that the remarkable amount of panel paintings which have undergone such drastic structural restoration often exhibit both complex and repeated surface and structural problems. One cannot emphasize enough the importance of the influence of climate, fundamental element for the conservation of panels, considering how thinned panels are almost exclusively of tangential section and how the supports cut this way tended to form on double axes X and Y. Moreover, the thinned panel reacts repeatedly to variations in relative humidity, and in addition, consider that the rigid systems attached on thin panels impede these movements, causing potential damage to the structure and paint film. At this point, it is permitted to ask, is an absolute system of controlled climate possible for a painting on panel? Is an acclimatized container secure, be it in a museum or enclosed space? How should the large quantity of works on panels in uncontrolled environments be treated? The stabilization of the support has been researched studying the application of moisture barriers using various materials including waxes, resins, and balsa wood, with the aim of slowing hygroscopic behavior. To slow the behavioral dynamics diminishes the susceptibility of the support to the phenomena that cause structural and superficial conservation problems. In attempting to reduce shrinkage and swelling, various other impermeable barriers, besides wax and resin, were researched and applied to the reverse of paintings on panel in an attempt to establish dimensional stability. Studying the relationship between paintings on panel and environment, R.D. Buck emphasized important concepts like those of dimensional stability and humidity barriers in a historic period in which it was attempted to introduce concepts of mechanics in restoration, in particular for the application of sophisticated support systems using new materials. The analysis of the behavior of humidity gradients already evaluated in the application of impermeable barriers has shown us how real the problems are of the inversion of gradients in the presence of total barriers, and it is this situation which creates increased instability with related conservation problems of the pictorial surface. Like R.D. Buck in his evaluations of moisture barriers, P. Mora in Rome in 1972, in a very clear way, returned to the concept of the permeable barrier. Quote, It would be therefore extremely opportune to study, to clarify, if possible, barriers whose permeability could approximate that of the paint surface, unquote. The application of a contact hygroscopic barrier, therefore, is no longer invasive and irreversible, but is actually removable, replaceable, and reversible, fulfilling the ideal concept of reconstructing the initial behavior of the panel before thinning by respecting the support and analyzing the humidity gradients. Beyond considerations of various materials, such as gums, synthetic polymers, polyethylenes, an ideal hygroscopic barrier could consist of a thickness of wood, an optimal natural buffering material. The application of this concept can be expressed as buffer effect coupled with time as a factor. Therefore, the phenomena of the absorption and desorption of moisture in the support is slowed down, and as a consequence of the related phenomena of swelling and shrinkage of the support itself is also reduced. The buffer effect of an implied hygroscopic barrier to the support can therefore allow us to considerably reduce the structural risks and those risks to the pictorial surface, positively contributing to the conservation of the work on panel. Our study consists in the use of a buffer system on the back of the panel with the scope of artificially reconstructing a behavior of the support similar to the initial gradients of humidity that it had originally, with the aim to slow down the reactions of the support to hydrometric fluctuations. It is proposed mostly for thinned panels, which are inherently more susceptible and more fragile in comparison to panels with complete and consistent thickness. It seems to be a partial solution to the fundamental factor of climate by means of a decrease in the response to fluctuations of relative humidity, simultaneously eliminating the control problems along the X and Y axes through a support system able to elastically control the movements of shrinkage and swelling through elastic movement along the line of deflection. Various types of systems can be employed here. In the photos being shown are some examples going back to the opificio delle pietre dure systems. One with basic elastic control of the y-axis is preferable with a spring system that allows precise determination of the contrasting forces and that also measures metrically the fluctuations of the spring itself in response to the movements of the panel. At the same time, the structure of the auxiliary support is constructed in wood of radial section and assembled like wood laminates. The wood further guarantees the possible flexibility of each and every crosspiece, measurable with exactness in the construction phase with a dial gauge, a kind of strain gauge. In this way, besides the single points of elastic control provided by the springs, the overall flexibility of each element of the strainer can be evaluated. The auxiliary support is applied after the panel has regained a curve that the tangential section induces by intrinsic behavior. The curvature assumed by the panel allows a reduction in the overall tension in the most tangential area of the support, reducing in tandem the projections of such tensions on the pictorial surface, such as delamination, lifting, loss of the paint film. The difficulty of being able to precisely stabilize the type of curvature the panel takes on is evident. The procedure used in our experience foresees working in a rigorously controlled environment with constant RH at 55%, where the work of art is placed in a phase of acclimatization, which varies according to the type of panel and the thickness of the support. Once the hygroscopic equilibrium of the support is scientifically verified with a moisture meter, the rigid support system is gradually removed until it is substituted with a temporary elastic support system. It is already possible at this point to use dial gauges to measure the forces exerted by the support during the first phase of curvature that the panel tends to assume. The resultant values will be very important for the selection and calibration of the elastic system that will be applied as an auxiliary support, let alone for the creation of the latter on the print of the curve itself. With gradual curving under constant environment, the forces expressed by the support during deformation will be known, and the curve reached by the support can be measured. By applying such an elastic strainer to the reverse of the thin panel, we can route out grooves to accommodate small wooden panels that function as a hygroscopic barrier with a buffering effect. The choice of the species of wood is dictated by the species used in the support of the painting, with the aim to find a common hygroscopic behavior. The thickness of the barrier depends on the thickness and condition of the support. The greater the thickness, the greater the buffering effect. The hygroscopic barrier of wood can be inserted into the strainer, positioning it directly in contact with the panel painting support, or detached with the aim of creating a space where another buffering material, like ArtSorb, can be placed. This material, already widely used during transit and in closed environments, is employed in our circumstances not to create a constant and stable microclimate, which actually is not possible considering the permeability of the hygroscopic barrier, but used with the goal of obtaining an effective buffer. Placing a sheet of ArtSorb as a buffer material between the support and the small wooden panel inserts notably increases the buffer effect of the panel support, slowing the time it takes to reach hygroscopic equilibrium, making the relationship between the thin support and the environment less direct. The hygroscopic filter slows down fluctuations in humidity, lengthening the absorption and desorption times. The system just described has been in use for a decade now and has been successfully applied to many paintings, including the Pietà Donna delle Rose by Giovanni Bellini in the Galleria dell'Accademia in Venice, a portion of the Dossale Corvisiere by Giovanni Baronzio in the Galleria Nazionale d'Arte Antica di Palazzo Barberini in Rome, 2 panels by Giovanni Bellini at the Galleria Strassmayer in Zagreb, and 2 panels by Lorenzo Veneziano in the Pinacoteca Nazionale in Bologna. In particular, we will focus on an important example, the Pala di Castelfranco by Giorgione, which was commissioned between 1503 and 1504 by Tuzio Costanzo for the family chapel in the Duomo di Santa Maria Assunta e Liberale of Castelfranco Veneto near Treviso, on the occasion of the death of his son Matteo. It depicts the Madonna and Child enthroned with St. Francis and St. Nicasio, the latter the patron saint of Treviso. This panel painting had notable problems with the surface and underwent several complete restorations. Among the interventions was the thinning and semi-transfer of some painted areas onto canvas, which were then reapplied onto the panel. The support, restrained by a heavy cradle that forced it into a flat plane, was the subject of a careful structural restoration, which lasted a year with the specific goal of obtaining a curved structure to be secured to a protective auxiliary support. The removal of the cradle was gradual, first reducing the number of cross battens, and then substituting the rigid cross battens with more flexible members. The panel was placed in a vertical position and gradually obtained a curve whose forces were evaluated with dial gauges. Once the planned curve was obtained with a deflection of 14 millimeters, by inserting even more flexible cross pieces, the painting was supported by wooden beams cut with the same curved profile as the panel and was freed of the remaining attached support. A laminated oak strainer was prepared, consisting of 5 cross pieces and 2 vertical members, and was assembled directly on the support using it as a guide. Only using light pressure, sufficient enough for gluing, with protective barriers between the painting and new auxiliary support. Using the assembled strainer, anchor points were placed in position on the support. The strainer is then positioned using the corresponding anchor points. In the spaces defined by the strainer, the small protective wooden panels were inserted in the groove routed out in the thickness of the strainer, with the aim of creating a buffer effect, as already described, increasing the presence of specific buffer material, in our case, Artsorb. The protective system on the reverse was completed and inserted into the elastic auxiliary support. Once the restoration was completed, the painting was included in an exhibition of Giorgione at the Galleria dell'Accademia, Venice. Following the show, it was returned to its original location in the family chapel in the Duomo of Castelfranco, Venezia, where it can be seen today. Allowing a thinned panel to find its natural state of equilibrium and curve reduces possible structural and surface damage caused by tension forces. The application of an elastic auxiliary support on a curved support enables an exercise of control over the deformation of the panel, and more so by integrating a buffer system on the reverse of the panel with the scope of artificially returning the response of the support to gradients of humidity to the pattern that it might have had originally. It is possible to slow shrinkage and expansion and associated deformation in response to humidity variations. The buffer function mitigates the response of the thin support to the environment and creates a function of hygroscopic filter that reduces the impact of extremes of external humidity cycles, preserving the work of art and improving its conservation. Thank you.